Alright, algebra fans, we're going to take a look at our notes today. The topic, Notes Day 39, solve systems of equations using substitution and elimination. Just to recap what we did yesterday, we looked at how we could solve these by graphing. If you graph two lines, the solution is always where they intersect. Okay, so intersect, that's the same thing as the solution or the answer. Now we talked a little bit about systems of equations. So the first thing we're going to do though is we're going to define this again. A system of equations. A system of equations is two or more equations with multiple variables. So if you have two equations, you're going to have two variables. If you have three equations, you'll have three variables. Now what it means to be a solution to a system. A solution is the values for the variables. The values for the variables that make all the equations true. That make all the equations true. It's the value for the variables that make all the equations true. So whatever x is, for example, in one equation, x is the same in the second equation. Whatever y is in the first equation, y is the same thing in the second equation, and those values have to make each equation true. So a couple of examples here. Number one, we're going to look at, you see this bracket here, that tells you this is a system. That means the x in the top equation, which I'll call equation 1, has to be the same value for x as in the bottom equation, number 2. The value for y in the top has to be the same as the value for y in the bottom. The question is 3 comma negative 1, that's x, is 3, y is negative 1, is that a solution to this system? Does it make both equations true? If you look at equation 1, okay, I'm going to do this down here. X plus y equals 2. I'm going to substitute. X is 3 plus the y value is minus 1. Now 3 plus negative 1 is 2. So the left side is 2, the right side is 2. Check. The top equation is good. How about equation 2? 4 times x. So 4 times 3 minus the y value is negative 1. So that's 12. And then minus a minus, those are both positive, so it's 12 plus 1. Now that equals 13. The right-hand side of the equation, though, should be 11. So 13 is not equal to 11. So it works for the top equation, but it does not for the bottom. So is this a solution? No. It is not a solution. It has to make both equations true, and the second equation is not true. It has to make it work. Number 2, is 4 comma 1 a solution to, here's the system. The top equation is negative 3x plus y equals negative 11. The bottom equation is 2x plus 2y is equal to 10. So let's go ahead and check it. X is 4, y is 1. So for the first equation, negative 3 times x, that's 4, plus the y value is 1. You get negative 12 plus 1, and that equals negative 11. The left-hand side is negative 11. The right-hand side is negative 11. Check. How about equation 2? Equation 2. 2x, so that's 2 times x plus 2 times y equals 10. The x values are x is 4. The y value is 1. So we get 8 plus, that's 2. Is that equal to 10? 10 equals 10. Check. Both equations are true with this ordered pair. So yes, that is a solution. That works. Okay, now I'm going to show you two ways of doing this. Yesterday we learned how to graph. That's one way. There are two other ways. that I'm going to show you today. The first way is called substitution. Basically what we do, here's the process. Now this isn't going to make sense really until we start doing the examples, but step one is to solve one of the equations for one of the variables. So you get x equals or y equals or whatever. You take that and substitute it into the other equation to solve it for the variable, one of the variables. Once you find one variable, you have to substitute again to solve for the other variable, and then you check your solution to make sure you get it correct. All right, so let's look at an example here, and this will make some sense. So solve. When you see the word solve, they're saying find x, find y. If it's a system, find the x, find the y. The top equation is equation 1. The bottom equation is equation 2. Now let's see. In our steps, step 1 is to solve the equation for one variable. Notice that the top equation is y equals. Well, that's good. And it's even better because it's y equals a number, 3. We already know what y is. We're halfway done. We just need to figure out x. So here's what we do. We're going to take this y value, we're going to substitute it into the second equation. So I'm going to take equation 2, which was x plus y equals 10. But instead of y, what can we substitute? Y is equal to 3. So I'm going to take a 3. I'm going to put that in the parentheses. Now we solve it. This is x. Let's drop parentheses, so just plus 3 equals 10. We'll go minus 3, move the constant. X equals 7. So we have x is 7, y is 3. The way we write the answer, we're going to write it as an ordered pair. X, comma, y. 7, comma, 3. Now the last step is to check the solution, make sure it works. The y is equal to 3. That's what we have. Top equation, check. Now the bottom equation, x plus y equals 10. Well, x is 7, y is 3. Does that add up to 10? Yes. Check. If both equations work, then this ordered pair is the answer. All right, let's take a look at number 4. Equation 1, equation 2. Notice equation 1 is already solved for a variable. X equals -6. That's good. So we already know what x is, we just need to find the y. Let's take this x value and substitute into equation 2. If x is -6 for the top equation, it has to be -6 in the bottom. That's what it means to be a system of equations. So, equation 2. 2 times x, parentheses, plus 3y equals 9. Now we know that the x value is -6, so I'm going to substitute -6. We can work this out now. 2 times -6 is -12 plus 3y equals 9. Let's move the constant, -12. To move this negative constant, we add 12 on both sides. So we get 3y equals 9 plus 12 is 21. One more step. This is 3 times y. We need to divide by 3 to undo that. Y equals 7. So the answer, we're going to write it as an ordered pair. X is -6, y is +7. Does it work? Well, this time I'm going to use the calculator to help me out a bit here. X equals -6, well that's good. How about the second equation, 2x plus 3y is equal to 9? So 2x, that's 2 times, x was -6, close parentheses, plus 3 times y, well our y value is +7. So 3 parentheses 7, the question is, does it give us 9? If it does, then we're good. You get the answer there, the value is 9. So that means the bottom equation also checks. Is this the solution? Yes, it's good. All right, let's go down here to number 5. Now number 5, equation 1, equation 2. Number 5 is a little bit different. The top equation is x equals. Well, that's great. The only problem is that it's not x equals 3, it's x equals 3y. So what we're going to do, same process, we're going to take the x value, we're going to substitute it into the bottom equation. So equation 2 was 3 times x minus 5 times y equals 8. The x value is 3y. So I'm going to put a 3y there. Now when you solve this, first thing you always do before you start moving stuff to another side is you combine all like terms. First thing, 3 times 3y, that's 9y, minus 5y equals 8. We can combine 9y minus 5y. They're on the same side. 9 minus 5, you get 4y equals 8. This is 4 times y. Now we solve it. Divide by 4, divide by 4. 4 divided by 4 is positive 1, so we get 1y, or just y, equals 8 divided by 4 is positive 2. So the y value is 2. Now we're not done. We have y, we need x. You can go back to equation 1 or equation 2 to figure out the x. But I always go to the simpler equation. Which one is easier or shorter? In this case, equation 1 looks a lot easier. It's already x equals. So what I'm going to do is take equation 1, x equals 3 times the y value. X equals 3y. Now what's the y value? We just solved it. Y is 2. So x equals 3 times 2. 3 times 2 is 6. So we get x is 6. So our answer, 6 for x, and then 2 for y. X comma y, there's the solution. Now again, let's check it. I'll just check it on the calculator here. X equals 3 times y. The y value is 2, so it's 3 times 2 equals 6. Check. The second equation, 3x, so 3 times 6 minus 5 times y, y was 2, that should equal 8. Enter. Yes, it does. Check. All right, we're good. So both of those work. 6 comma 2 is the answer. Let's do one more problem here, number 6. When you're doing these, you're always looking for the best way to do it because you're going to know 3 different methods. Equation 1 is y equals 2/3 x plus 4. Messy, but it's y equals, which is nice. Now equation 2, negative 3x plus 10x is equal to 7. Wait a minute. You only have one variable. These are both x's. So here's what we're going to do. Let's go ahead and just solve equation 2 right away. You can combine like terms. Negative 3x plus 10x is 7x equals 7. Divide by 7, and we get x equals 1. So we found the x value. Now we need the y value. Let's go back to the top equation. Let's go back to equation 1. I'm going to put the 1 value in for x. So we're going to write it over here. Y equals 2/3 times 1 plus 4. Now you can do 2/3 times 1 is 2/3 plus 4. Now you can write the answer 2 ways. Y equals 4.6 repeating. You can write it as a decimal or as a fraction, which is 14/3. So the final answer, which we'll write as an ordered pair, is x comma y. Now that's the end of the front of the notes. So what we're going to do, flip it onto the back, and we'll take a look at the second side in the second part of the video.